Hello everybody, and thank you for joining me for this SUSECON digital session on Rancher and vSphere. So in this session we'll be going over a lifecycle provisioning deep dive, so how under the hood does Rancher provision Kubernetes clusters onto vSphere. We will also look into in-tree and outer-tree cloud providers and finish off with a couple of demos. The first of which will be going over how to provision a kind of bog standard Kubernetes cluster on vSphere using Rancher, and the second demo will be kind of doing the same again, but augmenting the capabilities of a cluster by leveraging the vSphere outer tree cloud provider. So to kind of understand how Rancher provisions clusters onto vSphere, we kind of have to look back to a project called Docker Machine. So Docker Machine is essentially a utility that creates virtual machines on a number of different providers such as EC2, vSphere, Azure, etc. and it installs and configures Docker. So it's a very simple, very opinionated piece of utility that simply installs Docker. And this is important for Rancher because of how we install RKE. So RKE is one of our Kubernetes distributions, and it packages the Kubernetes components such as etcd, API server, etc. as Docker containers. So this removes a hard dependency between certain operating systems and makes it so that the only requirement we really have is Docker running on that machine. So we've effectively forked this project of Docker Machine and then we've turned it into Rancher Machine. So we've augmented the capabilities of Docker Machine to fit Rancher's use case. And in terms of operation, it behaves very similar to how Docker Machine used to behave. So again, it creates virtual machines on a number of different infrastructure providers and it installs and configures Docker, because then it forms a basis for us to turn it into an RKE node. And this utility is fully embedded into the Rancher platform as a standalone executable. So for example, if you were to exec into one of the Rancher containers and inspect the user bin directory, you'll find an executable labeled Rancher Machine, and that's essentially where it lives. And we invoke this when we create a Kubernetes cluster or an RKE cluster on an infrastructure provider such as vSphere. So its job is to take a node template that we've defined in Rancher and then convert it into a Rancher Machine command. So a node template in Rancher determines the characteristics of the virtual machines that get provisioned to make up an RKE cluster. So they will, for example, define the number of vCPUs, the amount of RAM. For a vSphere node template, it will define things such as the port group that it needs to connect to, which cluster should it reside in, and all that kind of stuff. So at a very high level, we have Rancher. One of its components is Rancher Machine. It will talk to the vCenter APIs to go and provision virtual machines on our behalf. So we need to SSH into these virtual machines that get created so that we can effectively turn it into an RKE cluster. And when we go over the node templates in a future demo, you'll notice that there's no kind of parameter set for defining the credentials for these virtual machines. And that's because we don't need to create them manually. So what Rancher will do is it will generate an SSH key pair. Currently this is kind of hard coded for the user Docker, and it will package it as cloud init user data. It will then kind of deliver this as a ISO image that gets mounted onto these virtual machines, and these VMs will ingest this data on first boot. So these virtual machines will ingest this SSH key, and that's how Rancher Machine is able to SSH to them without us defining explicit credentials. So you can expect this for yourself as well. So if you get Rancher to create an RKE cluster on vSphere, what you'll see is if you look at the hardware properties or the virtual hardware properties of the virtual machine, you can inspect the CD-ROM device. You'll have a look at the ISO image that's just labeled user-data.iso. If you extract the contents, you'll find a cloud config user data file that contains, for example, the user Docker and an SSH key. And this is instructions to that virtual machine on first boot to say, I want to create a user called Docker, and this is how it authenticates via an SSH key. And if we were to inspect the cloud init logs after the initial boot, we'll be able to identify that, for example, CloudInit has identified a source of data from an SR device. So an SR device is typically a CD-ROM device for Linux-based machines. And this kind of log indicates that it's identified some data, and it's going to ingest it, and it's going to give us a summary at the very end. So this is one of the troubleshooting steps that we sometimes go through if, for example, a machine is just waiting on SSH. So if Rancher is waiting for SSH into a node, we can effectively check this CloudInit log to see if it has actually ingested that data. And again, once we go through the logs even further, we can see it starts adding that Docker user. So we can see it's added a Docker user, there's some additional commands it's running, and we have a summary at the very end to say that this user has been added to this machine via, and it also is associated with a certain SSH key pair. And then if we go to some more generic logs, so like auth.log, we will see, for example, an SSH connection being made by one of the nodes that's running Rancher. So Rancher itself is a containerized application. It runs on a Kubernetes cluster. And what we'll find in the logs that one of the nodes that's accommodating Rancher will be making an SSH connection to it, because that's essentially what the Rancher pod's doing. So we can validate this connectivity by inspecting the auth log as well. So just as a recap, we have our node template that defines the characteristics of a virtual machine. Rancher then converts this into a Rancher machine command with various flags and arguments to kind of facilitate that particular template. It will then talk to the vCenter API, which will in turn generate some virtual machines for us. We will then mount an ISO file to these virtual machines that contain CloudInit user data for us to bootstrap the Docker user to. After which Rancher will initiate an SSH connection to those nodes to turn it into an RKE cluster. So I deal a lot with working with customers and prospects dealing with vSphere provisioning, and there's two major issues that comes up when they attempt to try and provision clusters onto vSphere. The first of which is this SSH connectivity. So Rancher, or the pods that constitute Rancher, need to be able to SSH to these nodes. And one of obviously the kind of key requirements is we need a valid IP address. So the way in which Rancher knows which IP address belongs to which node is we inspect the IP address that's been reported by VMware tools. So if, for example, you go to a virtual machine and the IP address field is blank, Rancher's not going to know what IP address to try and SSH into. It will by default pick the first IPv4 address to try and initiate an SSH connectivity to. So this also opens up a requirement to say that the nodes that are running Rancher need to have firewall access, they need to be able to route to these particular nodes. And the second is CloudInit. So has CloudInit ingested its SSH key? So as I demonstrated before, there's a couple of places for us to check. We can check the CloudInit log, we can check the audit log to ensure that that virtual machine has actually ingested that data. So next thing I want to talk about are in-tree and outer-tree cloud providers. So just to kind of roll it back a bit, what exactly is a cloud provider? So it's a module in Kubernetes that kind of acts as a glue between your cluster and your cloud provider's API. And it can abstract logic for things like persistent storage and load balancing. So as an example, Amazon have their own cloud provider. And if you were to enable it, what you'll find is if you wanted to, for example, provision a service of type load balancer, the cloud provider will talk to the AWS APIs and request an elastic load balancer object. Similarly for block storage. Now in vSphere, they have their own cloud provider, but in kind of bog standard vSphere, there's no real concept of a load balancer type unless you're using NSXT as a CNI. So we effectively use that primarily to address persistent storage requirements. And when Kubernetes was first made, it had kind of, and it still does to an extent, cloud providers as part of the Kubernetes code base itself. And that's where this term of in-tree comes in. It's part of the core Kubernetes code base. So within this code base, there are built-in cloud providers for the likes of AWS, CloudStack, vSphere, and others. And in-tree cloud providers are going to be deprecated. So the way in which we kind of need to address this looking forward is that where possible, we need to leverage outer-tree cloud providers. And the way in which in-tree cloud providers work is that we enable them as part of the Kubernetes configuration, which reconfigures components such as kubelet, and the kubelet itself will be making direct connection requests to the cloud provider's API to go and grab some of this metadata. Outer-tree cloud providers, however, reside with different logic. So instead of reconfiguring the kubelet, they're actually manifested as their own workload within the cluster. So it is kind of decoupled from the core Kubernetes codebase. So you're probably thinking, what's the point? What's the advantage of using an outer-tree cloud provider? So if you imagine you're a developer working on one of these cloud providers, if you wanted to add additional functionality or fix certain bugs, you'd be limited to the release cycle of Kubernetes for your code to be incorporated, tested, and then been made into a certain release. By moving all these outer-tree, the developers are given the opportunity to work on them completely independently of the Kubernetes release cycle. So they can implement new features, fix bugs in their own kind of time frame using their own scheduling. So this is essentially what's going to happen, and VMware have both in and outer-tree cloud providers that we can leverage. So that's enough for the slides. So what I'd like to do is switch to a couple of demos. So I'm going to log into an existing Rancher instance. So here, for example, I've got my own Rancher instance. It's currently managing a few clusters. The first of which is just a local cluster. So this is residing on K3s. We have a tools cluster. So this is where I have some of my own internal tooling. And I have a vSphere with cloud provider cluster that I'll be using in a bit. So the first thing I wanted to demonstrate is the node template. So I have an existing one here that I'll use to demonstrate. But this is how we are defining the characteristics of the virtual machine that gets provisioned. So we have some cloud credentials that define, how do I authenticate to a vCenter server and which vCenter server to authenticate to. And then I can define, for example, which data center, which resource pool, which data store or data store cluster that I want this particular node to reside within. And then we got the instance options. So for example, CPU, memory, disk, whether we want to, how we actually firstly get this virtual machine up and running. Do we clone from an existing template? Do we clone from an existing virtual machine? So in this case, I have an existing template that I leverage. I've got some additional cloud configs. So I mentioned earlier that Rancher will package some user data for the Docker user. We can add our own cloud init data as well. That simply gets appended to it. So if we wanted to add additional scripting, which is what I've done here to set a static IP address, we can do so. If we wanted to also add our own SSH keys to this node, we can do so. So this adds an additional layer of customization to those virtual machines that get provisioned. We have the port group that we want this virtual machine to reside in, some additional configuration parameters should we wish. We have some options for defining existing tags, some VApp options if we wanted to. So I've used this essentially as a glorified transport mechanism for a bunch of key value pairs that I use in conjunction with my cloud init script to go and define static IPs for my nodes. And then we give it a name, and then we can do some additional customization. So a couple of things I've done here. So my template already has Docker installed on it. So I've removed the Docker install script because, in my home lab, I try and make things as efficient as possible. I don't want to waste a lot of time downloading Docker for every single node that gets provisioned. So what I do is I install Docker on the template. That means I negate the need to actually run this install script. I also have a registry mirror. So I have a Docker pull through cache. That caches a load of images, which makes things a lot easier to use. So what I'll do then is I'll kick off a cluster installation using this node template. So just to go over some of the cluster provisioning types we have within Rancher. So the first of which is we can register existing clusters, we can create new clusters based on existing bare metal and virtual machines, but the option we'll be using is from the infrastructure provider. So all of these options here will use Rancher Machine in some manifestation. So Rancher Machine has a bunch of different drivers. We will then leverage this to create the infrastructure on this particular environment. So for this example, I'm going to click on vSphere, and the first thing I need to do is to give this cluster a name. So I'll just do DH demo. And the next thing I need to do is to define the anatomy of this cluster. And here we're defining what virtual machines get created and which roles they will assume. So as an example, what we can do is I can have multiple node pools, and I'll say, for example, I have one node pool for etcd, one for control plane, one for worker, and I'll say I want 3 etcd nodes, 2 control plane, and 4 workers. And we need to base this off a template. So this is the node template that I specified earlier. So we can actually mix and match these, so you can have different node templates that address certain roles. So as an example, for etcd, you'd probably want, a fair amount of CPU and high performance disks such as SSD. Your control plane nodes may not be so resource hungry, and you can pretty much specify your worker nodes based on what applications you're planning to run on this cluster. So for simplicity, I'm just going to add all here. And what I can now do is distribute the roles as I see fit. So in this node pool for etcd, I'm obviously going to specify etcd, and we have control plane and worker. So what Rancher enables us to do is to very easily define the anatomy of our cluster by dispersing these roles as we see fit. But for simplicity, what I'm going to do is I'm going to reduce it down to one node pool. I'm going to coexist all the roles, and I'm just going to create a single node cluster. So the next thing we can do is we can specify the Kubernetes options. So these are kind of the basic options that we have available to us. So we can, for example, specify the Kubernetes version. We can also specify a particular network provider. So these are kind of like the best hits of the CNIs that are available. We are looking to add more in the future. You can also bring your own. So if, for example, you wanted to install NSXT CNI, you can do so. You essentially provide the manifest for installing that CNI as an add-on to this cluster. Now here's where the cloud providers come in. So cloud providers are not mandatory. You don't have to use them, even if you are running a Kubernetes cluster on vSphere or Amazon. But you have the option to either specify a in-tree or out-of-tree cloud provider. So I'm just going to leave this as none for now. I have an existing cluster that we're going to use to configure the out-of-tree cloud provider for vSphere. We also have the ability to specify a private registry for this cluster. So I mentioned earlier that RKE packages these Kubernetes components as Docker containers. So we obviously need a place to pull them down from. By default, this is Docker Hub, but you can populate your own container registry with these RKE images to facilitate an air-gapped environment. Now we get to some of the more interesting options. So by default, RKE clusters will come with Nginx as an ingress. You can disable it, you can bring your own. We're completely agnostic. You can define as part of the cluster configuration to enable PSP support, but I won't go into further detail because PSP is unlikely going to be deprecated. We can also enable secrets encryption by default. One of the things we will also do is define a backup strategy for etcd. So we can either take snapshots of etcd, we can store it locally on the file system, or we can send it off to an S3 or S3 compatible storage device, and we can specify a schedule for this. We can also specify how many worker nodes we want unavailable in this cluster as part of cluster upgrade operations. So by default within Rancher, when we upgrade the version of Kubernetes in the cluster, we will upgrade the control plane in a graceful way that's non-disruptive. We add additional flexibility in how to address upgrading of worker nodes. So we can, for example, specify as a percentage or a static count how many worker nodes should be unavailable at a given point in time when we perform these cluster-wide operations. And then lastly, we have authorized endpoint. And this is the ability to authenticate and leverage a Kubernetes cluster without having to go through Rancher. So if you wanted direct access to the API server of this cluster, we can do so. So I'm going to click create, and I'm going to let this go. So if we go, for example, to the nodes, we can see that, it's interacting with vSphere. It will be provisioning a cluster. It will bring it all up. So that's going to take a few minutes. So I'm just going to leave that to do its thing whilst we have a look at the cloud provider example. So I've essentially done pretty much the same as we did with the previous example. The only thing I've done is I've specified an external cloud provider. So what this means is we need to go and actually install it. So by default, when you specify an external cloud provider, it will taint the node with this taint until we actually initialize a cloud provider. Now, VMware has a lot of documentation on how to do this. We've actually made it slightly easier within Rancher by incorporating it into our application catalog. So as an example, if we go into Cluster Explorer for this cluster, and then we go to Apps and Marketplace, we can see there's a couple of charts here for the cloud provider interface and the cloud storage interface. So the combination of this two effectively makes up the vSphere outer tree cloud provider. Now we have two because, well, they address certain characteristics, but also if you wanted to use the CSI, the storage provider, you'll have to install the CPI as well. So what we'll do is we'll go through the installation process for the cloud provider interface. So it's pretty basic in terms of what we need to do. So we just need to give it some vSphere credentials. So as an example, I'm going to give it a host. Give it a data center. I need to give it some credentials. So ideally, you'd use a dedicated account with lockdown privileges, but in my lab, I'm just simply going to use the administrator. And that's all we really need to do to bring up this cloud provider into this cluster. So you could actually have a look into the Helm chart yourselves if you wanted to go into further detail as to exactly how this all works under the hood. But in Rancher, we kind of abstract this away so you can very easily just get it up and running. So if we click on install, and we need to wait for a little bit. What this will do is it will install the CPI into that cluster, which it has done already. So what we should find as well is if we go to our cloud provider, we'll see it's removed that taint from that node because the cloud provider has been initialized. So what I'll also do is I'll install the CSI driver as well. So this is a slightly more involved process. So what we'll do is we will go and configure this. So again, we need to give it a host, data center, some credentials. We can migrate previous volumes created by the in-tree cloud provider. So there are options for migrating from in-tree to outer-tree, but this is on a per cloud provider basis. I'm not really using it in this cluster, so it's not applicable to me. So here we can specify a storage class for dynamic provisioning, and we need to give it a data store, or we don't have to give it a data store URL, but if we wanted to specify the data store URL that we want persistent volumes to reside on, we can do. We can also specify a storage policy, a vSphere storage policy that governs which data stores get included in this. And we have some more advanced node configuration, which isn't really required. So what I'll do is I'll just go and install this. So this will take just a bit of time. just to bring up those pods, download the images, etc., because it's simply just another workload. So we have, standard are kind of end user workloads. The external cloud providers are manifested as just additional workloads in the cluster. So if we, for example, take a kubectl shell to this cluster, get po-a, we'll see that we have vSphere CSI and Cloud Controller running. So this has implemented that external cloud provider. So that's pretty much how easy it is to get the external cloud provider working. And if I hop to a different cluster of mine, so this is another cluster that I have the cloud provider installed onto. So what we can do is we can have a look at some of the persistent volumes that it's made. So I have created some persistent volumes for some of my tooling within this cluster. So I have, for example, Prometheus running. I have a registry mirror. I am also evaluating HashiCorp Vault, and I've created persistent volumes for this. So under the hood, what will happen is when we request some persistent storage, it will talk to the vCenter API. It will request a VMDK. It will then mount it to the node that's running our workload, and the pod will eventually see it. So that concludes my presentation. Thank you very much for joining me. And yes, if you have any questions, feel free to reach out. Thank you very much.